Today's video is going to be a very simple video. It's going to be on relays and contactors, and what I'm going to try to get across to a few of you is the way that I would check a relay. I recently had an issue with a blower motor not working, and some people that I were around, they were like, hey, it's a new motor. So nobody ever used their meter to troubleshoot. They just assumed that because the motor wasn't turning, that the motor was the problem. And of course it wasn't. And then the capacitor got replaced, and then the thermostat got replaced, and there was a lot of assumptions. So today what I'm going to get across to you is what I would do and how I would do it as far as checking and troubleshooting for a, in this instance, for a blower motor not working. So let's look at some real quick items on a relay and remind you about a few things, and then we'll look at a Trane air handler that I have behind the camera. It's a TEM model, and it doesn't have a board in it like a Goodman. It just has a fan relay. So we'll walk through this. Shouldn't be too long of a video, but some very crucial basic information, and it seems that people have forgotten it. So let's turn to it and we'll get started. All right, so I got a couple components here, a relay, a contactor, I've got a meter, and we're going to start real simple. So what is a contactor and a relay? If you remember what you've learned about contactors and relays, if you've been through any training course or in the field long enough, right, this is a two-part component. And a contactor is real easy to see. You can identify where the 24-volt coil is. And this is more so residential stuff, right? There are contactors that have 120 volt coils, or a 208, 240 coil, or even a 460 in some, rooftop package units on the commercial side. But speaking just for like residential stuff, a real simple contactor is generally 24 volts, and that coil is controlled by the thermostat. And it may or may not have some low pressure switches or high pressure switches or some type of safety wired in series with that circuit. But generally on a contactor, the Y circuit ultimately ends at the contactor coil. And when that coil gets powered, it energizes, right? And it's going to cause this switch to react. Okay. And like I said, it's real simple. This is a one pole contactor. It's only a switch in one side. Depending on which way you hold it, it's the left or the right, no big deal. But it is a big deal. You should replace it just like it's in there. But don't forget that this is a two-part component, the coil and the switch. The switch shouldn't open or close until the coil does something, to cause that reaction. So the thermostat controls the coil controls the switch, and then the switch turns on the motors or turns off the motors. So too easy. While a contactor is pretty much a normally open switch or switches, relays tend to mess with people. So this is not the 9340 relay that I like. It's a real simple relay that's in this Trane air handler that we're going to look at, but it follows pretty much the same setup. And if you look at the side, all right, it gives you a very simple there we go. It gives you a simple depiction of what the internals look like. So terminals 1 to 3 is going to be, you can see a little squiggly line. That's going to be your coil. And you'll just look here and find terminals 1 to 3. And then it tells you terminals 2 to 4, it's open, and terminals 5 to 6 is closed. So it identifies that 2 to 4 is a normally open switch, and 5 to 6 is a normally closed switch. It's identical in its function to the 9340 relay that a lot of people have done some stuff on, and I've done my share of talking about it. So if you had to look, right, people get all nervous when you start adding wires to it and stuff, but if you were to take this thing apart, come on, there we go. If you were to take the top off of this one, you can't do that with the 9340. It's pretty much riveted in or whatever, but this little black pilot duty relay, you'll see a coil here, and then you'll see your switches. Okay, relays are a little bit different than contactors. They still follow the same premise, right? You got to get power to the coil in order for the switches to move and react to that. And with a relay, since this is going to be a fan relay, you'll probably generally see the 2 to 4 in this case, the normally open switch. That's going to be used to power the fan for cooling or for fan only operation. And then we'll probably use the normally closed switch to tie into our heat sequencer, so that when the heat strips come on, we can send power from that high voltage heater circuit through the normally closed to get our fan to come on with the heat strip. So typical stuff, nothing fancy. Coil at the bottom. This coil is going to be energized by the thermostat, and it's going to be tied into the G circuit, the indoor fan relay circuit. So once this coil gets power down here on terminals 1 and 3, then 2 and 4 will close and 5 and 6 will open. Too easy. What I think people are confusing themselves on is they're not remembering that there's two parts to this. Now, if either part is bad, then you get a whole new, a whole new relay. So if you go to a contactor and you say, oh, the coil is shorted, we don't replace just the coil anymore. It's not made that way. So you'll just get a whole new contactor. Or if, in the case of the contactor, the switches burn up. Maybe you had, some arcing or the pitted contacts on it. If the switch is messed up and the coil is fine, either way, you still replace the whole contactor. The fan relay is going to be the same thing. Doesn't matter if the coil is shorted out or open, or if the switches are burn up or something. Either part goes bad, you replace the whole. All right, but you have to know how to troubleshoot this. All right, so the switch is a switch. Switches are in line with one leg of power. Coils, they are a load, so they're going to see both sides of power. But you have to remember that the load is different than that switch. I can check these individually, the low voltage coil and then the high voltage switches. We can do those individually and still troubleshoot properly. So let me take you over here to the air handler, and we're going to look at it, and I'll show you how I would troubleshoot it, and might even go ahead and do one on the contactor coil or the contactor itself on the outside portion of this unit. Okay, so hang tight, and we'll look at the air handler. All right, so I've got my meter stuck up in the corner, and I'm going to try to keep it close enough for you to see and far enough out the way at the same time. All right, so I've got power onto the air handler, and here is my fan relay. Like I said, no circuit board in this particular case, and I'm going to walk you through the same problem that I've heard about recently. So this fan motor is not working, and the first thing you need to understand is the sequence of operation is that the thermostat calls for the fan to work. Okay, so if the thermostat was doing his job, and I'm not going to bore you to death with continuity checks and stuff like that. I mean, you know they're coming if you, depending on the problem that you got. But if my fan's not working, the first step I would do, since you've got the cover off to the air handler, is take your meter and go from the G terminal on the relay to the common, and I've got 0 volts. All right. Now, once I, prove power or something like that, and you can even check 24 volts out the transformer secondary if you want. But as far as I'm concerned right now, this relay is not turning on the fan because it hasn't been told by the thermostat. Now, I'm going to reach up here and turn the thermostat on. So I just turned on the fan from auto to on. And what I'll do, I think there's a slight delay in the thermostat, right? So what I'm doing now is I'll do the same check on the coil, and you can see I've got 26 volts. So from the common to the coil, the G to the C, right, is 26 volts. That means that coil is getting power from the thermostat. Now, let's say that, and I'm going to take this off real quick. Let's say that I got 24 volts on the relay coil, but my fan still didn't work. The next step I would do is still low voltage related. I would leave everything powered on, and this is me. I'm going to take the green off, okay? So no 24 hot. And what I'm going to do is I'm going to ohm out, or use continuity rather. Either one, I mean, they're both related. And I'm going to, just because you have 24 volts going to the coil terminals, doesn't mean you got a good coil. You could have an open coil and that 24 volts is not going to do anything. So while you're there checking 24 volts on those two terminals, go ahead and real quick take one of those wires off and ohm out the coil. So I did the continuity and you can hear it beeping. If you just switch it to ohms, right, I'm going to get the same thing, 78, 79 ohms. For me personally, ohm values are in my head, I make it real simple. If I see OL like you do here on the screen right now, right? Let me turn that up there. If you see OL on your when you ohm out a coil, then what that means is this: there's nothing there worth anything between these two leads. OL is a bad reading. If you see 0, which is what you get when you basically put the two leads together, that means there's no resistance there. So you basically go from both, both far ends of the spectrum, either all the resistance in the world being OL or no resistance. Both of those are bad. What I need, and John doesn't know every ohm value out there, but what I know I need is some positive number between 0 and infinity. And then I've got a starting point. In my mind, I can say, you know what? That's something like a load. At least the voltage has something to work with, and go from there. So once I've confirmed that I've got 24 volts to the coil and that I actually have a coil there to work with, now we're going to get into the switch part of things. So what I would do then is I would go back to volts on my meter. All right. Let me pan you back. I would go to volts on my meter and I'm going to check my air handler voltage. And I've got 208 in this case. Now, if you've seen any video I've done, like the high voltage hopscotch and even hopscotch with the low voltage or whatever, this is my terminal block, this is my power, it's a good source, and I'm always going to reference here. I think what messes a lot of guys up about switches is until you're mentally ready for it as a technician, you can check any terminal you want. Your meter's just going to tell you the difference in the voltage. But if you don't know what to expect, then this hopscotch thing is probably the best way to do this. So what I'm going to do is, I know that on a relay, since the switch breaks one side of power, on this fan relay, not a 2-pole contactor, but on this fan relay specifically, I know that I'm going to have L1 coming in, and that switch is going to break that contact, and L1 is going to eventually go out to turn it on, turn the fan motor on. So I'm going to keep one lead on L2, and I'm going to reference L1, right? And you can see here, I've got my 208 power source, my total voltage. A lot of guys, they dig in me on this, right? But I know I'm seeing my total voltage, so I know that I've got power sitting at that relay. I also know that L1 is only half that voltage, L2 is the other half, right? But work with me. I've got power going into that relay, and if I check, that was terminal 2 on the normally open switch, which it should be closed now that I've got power for G. If I check the other side and I've got the same 208, then that means that power went into the switch and then back out. If you were to check power in and then when you checked it coming out you get 0, that means that switch has not passed that power. Okay, power going in and not coming out, that's a bad switch. Okay, so I don't know how it is in your particular setup, but if you will reference the terminal block and find out L1 and L2, you can leave one lead there and follow power in and out of those switches. And when it goes in and don't come out, that might be part of your problem. So, but in this case, I've got the power on. Another way you could do this is if you were to take the wires off, right? A lot of guys are going to get me on this, right? I have disconnected the high voltage completely from this relay, all right? I'm going to move you so you can see it. I took the high voltage off completely. Now, this is a live circuit, so I'm sure somebody out there is going to mess with me, right? But you can hold this out the way, and the coil is separate than the switches. So if you had to, you could easily do continuity on the normally closed and say, hey, it's open. Now that's only half the check. The real check would be if you remove power on the low voltage. Did it go back closed? And it did, so that's good. Now, since I've got power off the coil, I'm going to ohm out the open side, and it's open, no beep. I got a beep when I touch my leads. I got no beep when I do the switch. If I were to reapply coil voltage, that switch should close. So, and it did. So, I mean, there's a couple ways you could do it. If you're familiar with the voltage on the switch, or if you have to use voltage reference to the terminal block, however you do it, but know that the thermostat controls the coil. If there's a good coil there, then that coil is going to control the normally open and normally closed switch in this case. Some relays only have one or the other, or some relays have both, or multiple sets of both. So make sure that the thermostat controls the coil controls the switch, and in this case, once the switch passes power out, we've got a PSC motor in our unit here. So if you have a PSC motor and the motor's not working and you verified low voltage to the coil, you verified voltage in and out of the relay switch, you may want to check your capacitor and then the motor. So, but a lot of people here lately have been blaming relays or capacitors or bad motors without troubleshooting, and this is just a snapshot of troubleshooting it. So I hope it makes a little sense to you. There's a couple guys that I'm trying to get this across to really, and I know that they'll probably watch this. So let me go check a contactor, and that'll be the last thing, and then we'll be done. Now, one thing I'll tell you too is if you have voltage to the coil, then the thermostat's not the problem. If you don't have any voltage here on your 24 volt connections to that coil, then don't blame the relay yet. You need to troubleshoot and find out where your 24 volts went, in this case on the G circuit. But if it's a contactor, you would make sure that if you don't have 24 volts on the contactor coil, then you would of course need to maybe troubleshoot low pressure switches or a float switch or something of that nature. But if voltage is there, then we're going to ohm out the coil if needed. If it's not there, then we're going to backtrack in the wiring and find out where the voltage went. Alright, so here we are on the outdoor unit for the air handler we just left, and what I'm going to do is keep the meter kind of off screen. I'm going to check the bottom here. I got no power. So if you're working with a PSC motor like a compressor that has the contactor and the capacitor and everything outside, I mean that's typical stuff, but the side of the contactor in this case is pretty much color coded. The Y is here and your common is on the other side, so it's the side terminals. But like I said, in the case of a contactor, this is pretty much a normally open switch. This particular Trane unit has a single pole contactor. So if I'm coming out here and I've got the outdoor unit's not running, one of the first checks I'm going to do is to the side of the contactor, and I've got, in this case, 0 volts. So what that means is the low voltage hasn't energized that coil yet. So I would then backtrack maybe to the wire nut connections for the defrost board or further back. All right. If you have 24 volts to the side of this contactor energizing the coil, and the switch here isn't pulling in, then the easiest thing to do, since you're right here, is to pop off one of the leads on the side, switch your meter over to ohms or continuity, and check the side of that coil for a resistance reading. In this case, I get 14.4. So I can safely say in my head that, hey, if this coil were to get powered, then it should move the switch. A lot of guys are going out here and they're pushing their finger on the contactor switch. That's not the way this is intended to work. So use your meter, If you have 24 volts, then the next thing I want to do is remove the low voltage wire on at least one side and ohm out the coil. You may not have a good coil there. You can have the voltage, but if there's not a load, if there's not a coil there to use that power, then it's not going to move that switch. So if you do have 24 volts there and you have a good coil and the switch isn't moving, then maybe there's something internal broken. You're probably not going to see that, but that's when we would go and we could do some voltage checks, or if you wanted to, you could remove the power off the bottom and do continuity through it, you know, something like that. You can treat it very much the same as a relay. It's just that to understand that this contactor only has, you know, a normally open switch. It's not like a relay where it's got or can have, you know, a different setup as far as normally open, normally closed switches. So, but that's what I would do. Check the sides. If I have power there, then I'm going to ohm out the coil and then proceed with the troubleshooting steps. If I do not have 24 volts, then you have to remember that the thermostat sends power to the coil, then the coil is going to energize and move the switch, then the switch is going to have to pass power, your high voltage power, to whatever motor, compressor, outdoor fan, indoor fan, you know, whatever you have. Even heat strips, I mean, the principle is still the same. So make sure you have your voltage from the thermostat. And the outdoor unit, like I said, the only thing I would really be worried about is if you have like a refrigerant leak, then your low pressure switch might be open, but you would backtrack from here to find out where your voltage stopped. It's going to be some type of switch more than likely. So, but anyway, I hope that makes a little bit of sense. Just trying to refresh a couple people's mind to make sure that you're troubleshooting as best you can. If we were going to guess at everything, we wouldn't buy all these tools. So the tools are what you need to master. You need to get the basics down in your head, and don't let something as simple as a bad relay or a bad contactor cause you to misdiagnose and then possibly, you know, get looked at funny by a customer when you tell them, hey, this is a bad, you know, $500 motor or whatever, and it's really just a simple, you know, $100 contactor. So troubleshoot it as best you can, do it right. If you have any questions, then let me know. Until next time. One other thing I'll tell you is, if you ever think that the fan motor is bad, the last little cheap trick I can tell you is to use something like this spade clip. One guy that I know, he calls this a bunny clip, B-U-N-N-Y, like a bunny rabbit, because it's got like 2 ears on it. And it's some guys call it a splitter. I'm not sure the exact nomenclature of it. What I usually do is take a real simple piece of wire with 2 male connections on it, and if you ever think that the relay is bad and you want to check the motor, you can easily put this little jumper in here and see if the motor starts working. You're essentially straight wiring the high voltage circuit for the motor to make sure that the motor is getting the proper power. In my case here, my terminal block does not have any male connection points that I could use, so this jumper wire would be great for me. If you did have some or a unit with a terminal block that did have those, you could easily just take this and plug it straight onto the power at the terminal block. So well, that's about it. Hopefully you understand a little bit about the relays and the contactors. Between diagnosing the thermostat properly and knowing how to troubleshoot it a little bit, and diagnosing a relay, making sure that you check the coil and the switches separately and together, you'll get a little bit better at properly diagnosing bad motors, bad capacitors, you know, bad relays and bad thermostats. So until next time, I'm out of here.